Hey guys, welcome to the end of round 3 of CPW. Today we practiced our science ACT skills. In our first question, we selected one piece of data from a complex data presentation. Then we performed a simple extrapolation using data and a table. Then we compared data from a simple data presentation and then identified the differences between two experiments. And then we performed a simple interpolation of data using a table, and then we identified the difference between two experiments again. We'll know we'll be successful when we can analyze the relationship between the variables given in a data table, when we can predict the answer reading past the data provided, when we can evaluate the results of two different experiments and determine the differences between them, and when we can predict an answer based on reading into data provided and comparing the results of the two experiments in question. In our first question, it asks, the results of the two experiments support the conclusion that for a given brand of tape, as the tape's width increases, the force required to remove the tape does what? So, looking at table 1, we see that as the tape width increases from 1 to 2 to 3, the average force also goes up. This pattern is seen for all brands of tape at all widths, except for table 2, for tape brand Z, because there's only one trial, so we can't really tell anything with that. But because the other 5 comparisons support this claim, we can say that the force required increases only, so the answer to number 1 is A. In experiment 2, had brand X tape in a 4 centimeter width been tested, the force required to remove the tape from the plastic wrapping would have been closest to what? So in this question, we're only focusing on brand X. We're only focusing on this row of table 2. But 4 centimeters was not tested because I don't see this number here. So we're going to have to draw an imaginary line where 4 centimeter width would be and look where our averages might end up. So at 1 centimeter width, it was a 1.6 newtons. At 2 centimeters width, it was 3.2 newtons. And at 3 centimeters, it was 5.0. So this data implies that our answer is going to be greater than 5. So that gives up A as an answer. But these numbers aren't going up drastically. They're going up in about segments or intervals of 2. So the best answer to 2 is B, 7 newtons of force. And our third question asks, based on the average experiments 1 and 2, which of the following brands of tape adhered better to the paper than to the plastic? So we have to compare paper versus plastic and compare the averages of similar tape widths to each other. So we're really hoping and looking for a better result with paper versus plastic. So that means that the paper number is going to be a bigger number, because the more force needed to remove it, the better it sticks, versus the plastic, which we're hoping are going to be smaller numbers or littler numbers in comparison. So looking at brand X at 1 centimeter width, it had an average of 1.9 versus on paper versus on plastic where it was 1.6. At 2 centimeters, it had an average of newtons of 3.9 on paper versus 3.2 on plastic. And then for 3 centimeters, the average amount of force needed to remove the tape was 5.8 on paper versus 5.0 on plastic. So right now, brand X follows the pattern that we wanted. We wanted the paper to have bigger numbers rather than plastic, which we're hoping was smaller. So this is an option. And so is C, because X is also embedded in C. For tape Y, 4.3 newtons of force were required to remove 2 centimeters worth of tape, and it's the same on paper and plastic. And at 2.5, it's also the same amount of newtons on paper and plastic. So Y is not going to be an option, which means that B is out, C is out, and D is out, meaning that A is our only option. In our last question, it asks, the student's instructor gave them a strip of tape that was 2.5 centimeters wide and asked them to identify the brand. So the students repeated the procedures from experiments 1 and 2 using the tape and obtained average forces for 4.9 newtons for paper and 4.1 newtons for plastic. Which of the following brands would most likely have produced these results? So there's a lot of things going on here. So we're going to take it one brand at a time. Remember that our goal for paper is 4.9 newtons. And our goal for plastic is 4.1 newtons. So over in table 1, if I put a line where 2.5 centimeters of tape would be, the line is in between 3.9 and 5.8. So 4.9 is an option. For tape brand Y, 2.5 centimeters has an actual result of 5.4, so tape brand Y is not going to be one of our options here. For tape brand Z, 2.5 would be, we're going to extrapolate a little bit, and it's an option. It could be 4.9, but it seems really unlikely considering that we had a pretty big jump from 1.9 to 3.9, and going up a half a centimeter may or may not get us to our 4.9 goal. But for plastic, our goal is 4.1 newtons. So if we interpolate in this data table, 2.5 would give us an answer probably about around 4.1, because the difference between that is 1.8 divided by 2 is 0.9, and that gives us 4.1. And then jumping down to Z, because we already determined Y is not an option, there's too big of a jump to really tell. So Z is out, which means that A, brand X only, is our best option. So to recap, our answers for this week's CPW Science are 1A, 2B, 3A, and 4A. See you next round.